My dear bacha log, so in this question we have to, one second. So in this question bacho, there is a capacitor, charged capacitor is disconnected from a battery. Now if the plates are separated further, what will happen to the potential energy? So bacha log, remember, the potential energy of a capacitor can be written as half CV square. It can also be written as Q square by 2C. Now in this case beta, the battery is disconnected. That means that the charge remains constant. That means that even if we increase the distance, the charge remains constant. And in that case beta, I will not use this formula, I will use this formula because that will be more convenient. Now U is equal to Q square by 2C, my dear bacha log. Now C is A epsilon naught by D, so I will just write down Q square by 2 into A epsilon naught by D. Now from this formula it is very easy to see that if D is increased, then in the same proportion the potential energy also increases. And therefore beta, the assertion is false. Okay. So if the assertion is false, you do not even need to look at the reason beta. Option D would be the correct answer. Assertion and reason are false. But here in this case beta, what you can say is that reason is also false because energy stored in the capacitor is not equal to work done in separating the plates. It is equal to the work done to charge the capacitor. In this next question, a parallel plate air capacitor is charged to a potential difference of V volts. After disconnecting the charging battery, the distance between the plates is increased using an insulating handle. As a result, the potential difference between the plates does what? So beta, here once again what you have to understand is that the battery is disconnected. Whenever the battery is disconnected, you have to realize that the charge remains constant. Now initially, my dear bacha log, the potential difference can be written as, since Q is equal to CV, I can write down V is just equal to Q by C, or V is equal to Q upon A epsilon naught by D. Now beta, what you have to understand is that if here D is increased, then in that case the potential difference will also increase in the same proportion, because when distance increases, potential difference will also increase. So option C will be the correct answer. In this question beta, a parallel plate capacitor is made up of two plates. Each has surface area 40 cm square and they are separated by a distance 0.4 cm. Now a material of dielectric constant 10 is introduced between the plates. We have to find out the capacitance. So capacitance, my dear bacha log, is given by Ka epsilon naught by D. Here K is the dielectric constant. Here beta, I will just substitute all the values. K is given as 10. Area is given as 40 centimeter square. So I will write down 40 into 10 power minus 4. Epsilon naught beta is 8.85 into 10 power minus 12. And D, my dear bacha log, is nothing but 0.4 centimeter. Now if you solve this beta, this will just come out as 88.5 into 10 power minus 12 farads, that is 88.5 picofarads. Option B will be the correct answer. In this question beta, the potential gradient at which the dielectric of the condenser just gets punctured is called what? So my dear bacha log, understand that between the plates of a capacitor, when we add a dielectric, what happens is that at a certain instant, if the electric field between the plates is very very high, at a certain instant, the dielectric breaks down and it starts conducting electricity. If E is very 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 high, then the dielectric breaks down. What do I mean by it breaks down, my dear bachcha log? It starts conducting electricity, lets the charge pass through. Now the value of electric field at which this breakdown occurs, the value of the electric field, my dear bachcha log, at which this breakdown occurs is called dielectric strength. Now here beta, therefore the answer will be option B, dielectric strength. In this question, my dear bachcha log, the capacity of a parallel plate capacitor is 5 microfarad. When glass plate is placed between its two plates, the potential difference reduces to 1 by 8 of its original value. The dielectric constant of the glass is what? So in this case beta, imagine initially this is the situation. The capacitance is 5 microfarad and the charge is plus Q and minus Q. Now what happens is that we are introducing a glass plate in between. Okay, let's say that glass plate has a dielectric constant K. So C dash beta, the new capacitance, will be K into 5 microfarads. The charge beta will still remain the same. Now if you compare the potential beta, initially the potential will be equal to Q by 5 microfarads, and finally beta, the new potential will be Q by C dash, that will be Q by K into 5 microfarads. Now of course beta, the question says that the new potential difference is original potential difference divided by 8. So Q divided by K into 5 microfarads, my dear bachcha log, is nothing but 1 by 8 into Q by 5 microfarads. Here beta, everything else will get cancelled out and K will just be 8. Option D would be the correct answer. I hope you guys understand. In this question, a capacitor is charged by using a battery and is then disconnected. The dielectric slab is then slipped between the plates. We have to figure out what happens to the potential difference, stored energy and the charge. So bachcha log, understand that whenever the battery is disconnected, the charge always remains constant. When we insert a dielectric, after disconnecting the battery, the charge remains constant. So here the charge will still be plus Q and minus Q. The new capacity beta will just become Kc. Now we can talk about everything else in this case. The original potential difference would be Q by C. The new potential difference beta will be Q by Kc. Q by C dash, which is equal to Q by Kc. That beta will give you the new potential difference as V by K. The original energy stored beta will be Q square by 2C. The new energy stored will just be Q square by 2C dash. That will be Q square by K multiplied by 2C. That will be U by K. So if you see my dear bacha log, here the potential difference is decreasing, the energy stored is also decreasing, but the charge remains the same. The charge on the capacitor plates remains the same. Because the battery is disconnected, charge does not change. So option C will be the correct answer. In this question, a dielectric capacitor is filled with a capacitor is filled with a dielectric K is equal to 3, has charge Q naught, voltage V naught, and electric field E naught. If the dielectric is replaced with another one having K is equal to 9, then the new values of the charge, voltage, and field will respectively be what? So, my dear bacha log, the capacitance of a parallel plate capacitor is Ka epsilon naught divided by D. Now, originally, my dear bacha log, the capacitor has charge Q naught and the capacity 3A epsilon naught by D. Now, my dear bacha log, that dielectric is replaced with a dielectric of constant 9. So, the new charge will remain the same beta because the battery is not connected, but the new capacity will be 9A epsilon naught by D. That is nothing but 3 times the original capacitance. Now, if you look at the potential difference, original potential difference would be Q naught by C. The new potential difference will be Q naught by C dash, that will be Q naught by 3C, and that will be V naught by 3. The original electric field, my dear bacha log, was V naught by D, where D is the distance between the two plates. The new electric field will just be V dash by D, that will be V naught by 3D, that will be E naught by 3. So the charge remains the same, potential becomes 1/3, electric field becomes 1/3. Option D would be the correct answer. In the next question, my dear bacha log, the space between two plates of a condenser is filled with dielectric medium of thickness T1 and T2 and dielectric constant K1 and K2 respectively. We have to calculate the capacity of this condenser. So, my dear bacha log, in this case, what I will do is I will think of it as two different capacitors in series. The first capacitor C1, my dear bacha log, is given as K1A epsilon naught by T1, and the second capacitance C2, my dear bacha log, is given as C2 is equal to K2A epsilon naught by T2. Now, my dear bacha log, the equivalent capacitance will just be given by 1 by C1 plus 1 by C2. That will be, my dear bacha log, 1 by A epsilon naught into T1 by K1 plus T2 by K2. Now, if you do a little bit of mathematics here, beta, this will be 1 by A epsilon naught into T1 K2 plus T2 K1 divided by K1 K2. So C equivalent, my dear bacha log, will be A epsilon naught into K1 K2 divided by T1 K2 plus T2 K1. So if you see, option C will be the correct answer. In the next question, a capacitor is connected to a 10 volt battery and collects a charge of 40 microcoulomb with air as dielectric and 100 microcoulomb with oil as dielectric. What is the dielectric constant of the oil? So initially beta, what I will say is that when air is there, I will write down Q is equal to CV, which gives me 40 microcoulomb is equal to C into 10 volts, which gives me initially C as 4 microfarads. Now beta, when oil is introduced, I will write down Q dash is equal to C dash into V. Substitute the values. 100 microcoulomb is equal to C dash into 10, which gives me the new capacitance as 10 microfarads. Now my dear bachcha log, understand the new capacitance is always equal to K times the original capacitance. So 10 is equal to K times 4, which gives me K is equal to 2.5. 10 divided by 4 is 2.5. Option C will be the correct answer. In this question, my dear bachcha log, the capacity of a parallel plate condenser increases 4 times if the air in between is replaced by glass. Find the permittivity of glass. So beta, in this case, the capacitance is increasing by 4 times. That means K is equal to 4. Now, this is, my dear bachcha log, the dielectric constant, but this is also called relative permittivity. This is called dielectric constant. This is also called relative permittivity. We can also call it epsilon R. Now, my dear bachcha log, the permittivity is nothing but epsilon naught into epsilon R. Permittivity of any material is permittivity of vacuum into relative permittivity, which gives me beta 8.85 into 10 power minus 12 multiplied by 4. That will be 3.54 into 10 power minus 11. So option A will be the correct answer. In this question, the capacity of a parallel plate capacitor in air is C. It is then filled with a dielectric of constant 5. We have to find the percentage increase in the capacitance. So beta, the original capacitance will be equal to C. The new capacitance C dash will be equal to 5 times C, because the dielectric constant is 5. Now I have to calculate the percentage increase in capacitance. That will be equal to the new capacitance minus the original capacitance whole divided by the original capacitance into 100. That will be beta equal to 5C minus C by C into 100. That becomes 400%. Option A will be the correct answer. In this question, a parallel plate capacitor has a separation of D and a capacitance of 25 microfarad. Now a metallic foil of thickness 2.2 by 7 D is introduced in between the plates with the same cross-sectional area as that of the plate. We have to calculate the new capacitance. So in this case, my dear bachcha log, I have one capacitor with initial separation D between the two. Now its capacitance beta is given as 25 microfarads. Very good. Now beta, what happens is that a metallic plate of thickness 2 by 7D is introduced in between. So this is still D, but now we have a metallic plate in between of thickness 2 by 7d. Now let's say beta, the distance remaining on both sides is x and y. So you can say that x plus y plus 2 by 7d is equal to d, which gives me x plus y is equal to 5d by 7. This will become important later. Now beta, since this is a metallic plate, what we can say is that it essentially divides, the metallic plate divides this into two separate capacitors. One capacitor with a thickness of x and another capacitor with a thickness of y. Both of them in series. Now C1 beta will be nothing but A epsilon naught by x, and C2 my dear bachcha log will be A epsilon naught by y. Their equivalent capacitance, let's just call it C dash, will be 1 by C1 plus 1 by C2. That will be x plus y upon A epsilon naught. That will be nothing but 5d by 7 upon A epsilon naught. That means, my dear bachcha log, the new capacitance C dash will be 7 by 5 into A epsilon naught by d. Now we already know that A epsilon naught by d is 25 microfarads. So the new capacitance, my dear bachcha log, will just become 35 microfarads. Option B will be the correct answer. In this question, there is a parallel plate capacitor in which a thin metallic plate is introduced in between the two parallel plates of area A and separation D. So beta, the original capacitance, let's say, is this. The separation between the two is D. And now we are adding one thin metallic foil in between, thin metallic plate in between. Let's say this distance is x, let's say this distance is y. Now x plus y, my dear bachcha log, will just be d. What this thin metallic plate does is beta, it divides the capacitor into two parts. One of capacitance x, the other one of one of width x, the other one of width y. Their capacitance C1 and C2 can be written as A epsilon naught by x and A epsilon naught by y. Now their equivalent capacitance will be 1 by C1 plus 1 by C2. That gives me 1 by C dash is equal to x upon A epsilon naught plus y upon A epsilon naught, which, my dear bachcha log, if you see, will just become x plus y by A epsilon naught or d by A epsilon naught. So the new capacitance will still be A epsilon naught by d, which is option A. In this question, my dear bachcha log, I have a parallel plate capacitor with the separation between the plates 3 mm and air in between. Now 1 mm thick layer of a material of dielectric constant 2 is introduced in between the plates, due to which the capacity increases. Now in order to bring the capacity to the original value, what should be the separation between the plates? How should we increase the separation between the plates? So in this case beta, originally let's say the separation is equal to 3 mm. That is what is given to us. Finally beta, let's say the separation increases to d dash. I increase the separation to d dash. and a dielectric slab is added in between of thickness 1 mm and dielectric constant 2. Now, in this case, let's say this distance is x and y. You should know that x plus y plus 1 mm is equal to d dash mm. Let's take the value of d dash in mm. So x plus y will be nothing but d dash minus 1 mm. Now, if I try to calculate the capacitance, here I have to take it as the 3 separate capacitors in series. One of thickness x, the other one of thickness 1 mm, and the final one of thickness y. The middle one will have a dielectric slab of constant 2. So their capacitances beta will be C1 is equal to A epsilon naught by x, C2 is equal to 2A epsilon naught by 1, and C3 is equal to A epsilon naught by y. Now my dear bachcha log, the equivalent capacitance will be equal to 1 by C1 plus 1 by C2 plus 1 by C3. That will be equal to x by A epsilon naught plus half by A epsilon naught plus y by A epsilon naught. Now this can just be written as x plus y plus half by A epsilon naught. If you see beta, this will just become d dash minus 1 plus half upon A epsilon naught. Now this needs to be same as the original capacitance. The original capacitance, my dear bachcha log, is just A epsilon naught by 3 mm. So if I equate the two, my dear bachcha log, let me do that in the next slide. A epsilon naught by 3 should be equal to A epsilon naught upon d dash minus 1 plus half. If you solve this beta, you will get d dash is equal to 3.5 mm. So option C will be the correct answer. In this question, my dear bachcha log, the distance between the plates of a parallel plate condenser is 8 mm and the potential difference is 120 volts. If a 6 mm thick slab of dielectric constant 6 is introduced in between, then we have to talk about the charge and the potential difference for the capacitor. Now, my dear bachcha log, if the battery is not connected to the capacitor, what you have to understand is that the charge remains constant. If the battery is not connected to the capacitor, the charge remains constant. If I have plus Q here and minus Q here, then here also the charge will be plus Q and minus Q. The charge remains constant. So option A and B cannot be correct. Now let's say the original electric field was E. The original distance between the plate is 8 mm. So my dear bachcha log, what I can say is V is equal to E into D, which gives me 120 volts is equal to E into 8 mm. E is equal to 120 divided by 8 mm. Now finally beta, what is happening is that I am adding a dielectric slab of constant 6 and thickness 6 mm, and the remaining space beta will have a thickness of 2 mm. Now here the new potential difference, my dear bachcha log, can be written as V dash is equal to E1 at D1 plus E2 D2, where E1 is the electric field inside the slab and E2 is the electric field in the remaining region. Now beta, inside the slab the electric field becomes 1 by k times. So I will write that electric field as 1 by 6 multiplied by the original electric field into the width d1, which is 6 mm, plus outside the slab beta the width the electric field remains the same. So I will just write down the original electric field into the width d2. Now that will become, my dear bacha log, 120 divided by 8, 30 divided by 2, that is 15 volts, plus 120 divided by 4 is 30. So that will become 45 volts. Option D would be the correct answer. The new potential difference would be 45 volts. In this question, my dear bacha log, the capacitor has a capacitance of 1 microfarad when with air. It is filled with two dielectrics as shown in the figure. How many times the capacity will increase? Now, my dear bacha log, what I will say is that originally the 1 microfarad capacitor is going to be A epsilon naught by D. Now beta, what I am doing is essentially I am adding 2 dielectric slabs in between. And I am adding 2 dielectric slabs in between. One slab is like this and another slab is like this. I can think of it, my dear bacha log, as 2 capacitors in parallel. That is how you can think of it. 2 capacitors in parallel. What will be the capacity of each capacitor beta? Let's call them C1 and C2. So C1, my dear bacha log, will be K1 into A by 2 epsilon naught by D. That will be equal to 8A by 2 epsilon naught by D. That will be equal to beta, if you think about it, it will be 4A epsilon naught by D. And C2, my dear bacha log, will be K2 into A by 2 epsilon naught by D. The area beta will become half because the dielectric slab is only there in the half region. Now that will become 4A by 2 epsilon naught by D. That will be 2A epsilon naught by D. The equivalent capacitance beta in this case, C dash, will be C1 plus C2. That will be 4 plus 2A epsilon naught by D. That will be 4 plus 2A epsilon naught by D. What happened here? 4 plus 2A epsilon naught by D. That will be, my dear bacha log, 6 microfarads, because A epsilon naught by D is 1 microfarads. So as you can see, the capacitance becomes 6 times. Now in this question, my dear bacha log, one second, let me increase the volume. Yes, in this question, my dear bacha log, what is happening is a parallel plate capacitor with air in between the plates has capacitance of 9 microfarads. Now the separation between the plates is D. The space between the plates is now filled with 2 dielectrics. One of them has a constant 3 and width D by 3. The other one has a constant 6 and thickness 2D by 3. We have to find out the new capacitance. So the original capacitance, my dear bacha log, 9 microfarads, is nothing but A epsilon naught by D. Here the width between the distance between the plates is D. Now if you make the new situation, what happens is that I am adding two slabs in between. This is the first slab, this is the second slab. One of them having width d by 3, the other one having width 2d by 3. Okay, and dielectric constants 3 and 6. So what I can think of it as beta as two capacitors in series. One with dielectric constant 3 with d by 3. The other one as dielectric constant having dielectric constant 6 and with 2d by 3. Now the capacitance of the first capacitor, my dear bacha log, will be equal to 3a epsilon naught upon d by 3. That will be 9a epsilon naught by d. That will be beta 81 microfarads, because a epsilon naught by d is 9 microfarads. And C2, my dear bacha log, will be 6a epsilon naught upon 2d by 3. That will be equal to beta once again 9a epsilon naught by d. That will once again be 81 microfarads. So what will be the equivalent capacitance, my dear bacha log? I can write the equivalent capacitance as 1 by C1 plus 1 by C2. That will be 2 by 81. So the equivalent capacitance will be 81 by 2 or 40.5 microfarads. Option C. In the next question, beta, between the plates of a parallel plate condenser, a plate of thickness T1 and dielectric constant K1 is placed. In the rest of the thickness, another plate of thickness T2 and dielectric constant K2 is placed. If the capacitance has charge Q, we have to find the potential difference. So beta, here you have a capacitor with two dielectric slabs, one of them having constant K1, thickness T1. The other one, my dear bacha log, having constant K2 and thickness T2. The charge is given as plus and minus Q. We have to find out the potential difference. So first of all, my dear bacha log, we will find out the equivalent capacitance. We can think of it as two capacitors in series, C1 and C2. C1 beta having dielectric constant K1, thickness T1. C2 beta having dielectric constant K2, thickness T2. Okay, now C1, my dear bacha log, will be K1a epsilon naught by T1, and C2 beta will be K2a epsilon naught by T2. So the equivalent capacitance, my dear bacha log, will just be equal to 1 by C1 plus 1 by C2, which when you do the calculation beta, it will be 1 by a epsilon naught into T1 by K1 plus T2 by K2. Now if the overall potential difference is equal to V, I can write down the potential difference, the total potential difference, as charge divided by equivalent capacitance, or charge into 1 by C dash. That will be nothing but Q by a epsilon naught into T1 by K1 plus T2 by K2, which, my dear bacha log, when you see, is option A, matches with option A. Next is this question. Here, when the space between the metallic plates is completely filled with conducting slab of capacitance, the capacitance of the parallel plate capacitor becomes infinite. If the electric field inside the conductor is 0, then this results in potential difference between the two plates to become 0. So my dear bacha log, what you need to understand is that in this question, the assertion is that the capacitance becomes infinite. Okay, now you can think of capacitance beta as charge divided by potential difference. And you can think of potential difference as equal to E into D. Now for conductors beta, you must remember from the chapter electrostatics, for conductors, inside conductors, the electric field is always equal to 0. And therefore, my dear bachcha log, the potential difference will also be 0. So the reason is true. It is very, very true. But how does that explain, my dear bachcha log, the assertion? See, capacitance is Q divided by V. If this V is tending to 0, then you have to realize that the capacitance tends to infinity. So therefore beta, assertion is also true. Assertion is true, reason is true, and the reason correctly explains assertion. Option A will be the correct answer. Next is this question beta. Here 3 conductors of capacity 3, 4 and 5 microfarads are connected in parallel. We have to calculate the total capacitance. This is a very nice, straightforward and simple question beta. Here 3 capacitance 3, 4 and 5 are connected in parallel. What will be the equivalent capacitance? That will be 3 plus 4 plus 5. That is equal to 12 microfarads. Option A will be the correct answer. In this question, 2 capacitors, 2 microfarads and 6 microfarads are connected in series. We have to calculate the equivalent capacitance. So beta, the first capacitor is 2 microfarads, second capacitor is 6 microfarads. We have to calculate the equivalent capacitance. I will write down 1 by C equivalent as 1 by 2 plus 1 by 6, which my dear bachcha log will be equal to 4 by 6. So equivalent capacitance beta will be 6 by 4 or 3 by 2 microfarads, which is option B. In this questions, 3 capacitors are first connected in series and then connected in parallel. We have to calculate the ratio of equivalent capacitance in the 2 cases. So first let's connect them in series, my dear bachcha log. I have 3 microfarads, 9 microfarads and 18 microfarads. If I want to calculate equivalent capacitance in series, I will write it as 1 by 3 plus 1 by 9 plus 1 by 18. Since beta the LCM is 18, I will write it as 6 plus 2 plus 1 divided by 18. That is just going to be 9 by 18 or 1 by 2. So the equivalent capacitance in series is 2 microfarads. Now when I connected in parallel beta, equivalent capacitance is very, very easy to calculate. They are just connected like this beta. Okay, 3, 9 and 18. The equivalent capacitance in parallel is going to be 3 plus 9 plus 18. That is equal to 30 microfarads. So what will be the ratio CS by CP? That will be 2 by 30. That will be 1 by 15. Option A will be the correct answer. In this question, the equivalent capacitance between point A and B we have to calculate. So first beta, what I will say is that A and B are in series. Let's say their equivalent capacitance is C1 and 2 and 2 are also in series. Let's say their equivalent capacitance is C2. Now C1 beta can be written as 1 by C1 as 1 by 3 plus 1 by 6. That gives me C1 is equal to 2 microfarads. And C2, my dear bachcha log, is 1 by 2 plus 1 by 2. That gives us C2 as 1 microfarads. What will be the equivalent capacitance, my dear bachcha log? Equivalent capacitance will just be equal to 2 plus 1. That is 3 microfarads. Option D will be the correct answer. I hope you guys are understanding. In this question beta, we first have to calculate the equivalent capacitance between A and B, then we have to calculate the equivalent capacitance between A and C, and then take their ratio. Now here beta, I will redraw the circuit two times. When we are talking about A and B, I will draw the circuit like this, A here and B here. Let's forget about point C for a minute. And your circuit will be like this. There is a capacitance between A and B, and then there are three capacitance in series. Like this. Now each of them beta has capacitance 3 microfarad. Correct? So I can very easily calculate the equivalent capacitance. This will just become beta 3 microfarad and in parallel 1 microfarad, which gives me the equivalent capacitance CAB as 4 microfarads. Similarly, I will redraw the circuit for A and C, and this time I will forget about B. Now, if you draw the circuit between A and C, if you see between A and C, these two are in series and these two are also in series between A and C. So when you redraw the circuit, you redraw it like this. There will be two capacitors like this, and there will be two capacitors like this. 3, 3, 3 and 3. Here beta, if you simplify this circuit, it will become something like this. 1.5, 1.5. Which gives me the equivalent capacitance between A and C as 1.5 plus 1.5, that is equal to 3 microfarads. So the ratio beta CAB is to CAC. The ratio of the equivalent capacitance will be 4:3. Option A will be correct. In this question, my dear bacha log, the connections are as given in the figure, and we have to calculate the equivalent capacitance. Now first of all beta, if you see the 2, 2 and 2 are in parallel, so I can just simplify this circuit as 1, 6 and 1, because 2, 2, 2 in parallel beta will just become 6. Then beta, calculating equivalent capacitance is very easy. 1 by C equivalent is equal to 1 by 1 plus 1 by 6 plus 1 by 1. That will be 6. That will be 6 plus 1 plus 6 whole divided by 6. That will be 13 by 6. So equivalent capacitance beta will be 6 by 13. Option B will be your correct answer.